and there is need of why we need modulation. Baseband signal transmission cannot be used for radio communication. That is, we know we see in first chapter that we can not use baseband signal we cannot use baseband signal transmission because radio communication because original signal is very low frequency and it cannot go to radio communication. To transmit the baseband signal for radio communication, modulation must be used. Modulation is very compulsory for radio communication. From very high frequency is needed for transmission from far distance. Modulation is necessary because of following advantages. Modulation is very necessary because of following advantages, that is reduction in height of antenna, avoids mixing of signals, increasing the range of communication, multitasking is possible, improves quality of reception, avoids mixing of signals, baseband baseband signal 2, baseband signal 3 can transmit using individual transmit using modulation process. It cannot interfere each other. And then we come to classification of modulation. Modulation we already see that modulation is two types: analog modulation and digital modulation. So in analog modulation, amplitude modulation and angle modulation are there, and pulse and angle analog modulation. And digital modulation there is pulse code modulation, delta modulation, and adaptive delta modulation. Okay, so first we see analog modulation in which amplitude modulation. In amplitude modulation they are further divided into DSB. DSB matlab double side band full carrier, DSB SC double side band suppressed carrier, SSB single side band, VSB vestigial sideband. TSB is a full USB in which there is USB upper sideband, lower sideband, and your sideband. Upper sideband there are two upper sideband, there are two lower sideband. That what it is called double sideband full carrier. And double sideband suppressed carrier, there is suppressed carrier, suppressed upper sideband, suppressed lower sideband, and suppressed and two separate upper sideband and two separate lower sideband. That's why it is called DSB SC suppressed carrier. And SSB single sideband, in that there is only one USB upper sideband and only one LSB. Okay, and vestigial sideband, there is small part of vestige. It is called vestige is used because it is used in TV signals. In angle modulation there is frequency modulation and phase modulation. Angle modulation is frequency modulation, that is frequency in which the frequency of the carrier is changing according to modulation signal. In phase modulation, the phase of the carrier signal is changing according to modulation signal. But phase modulation is not used because it is very complicated. It is very complex. Only frequency modulation and amplitude modulation is used. Okay, then comes to pulse analog modulation. Pulse analog modulation is further divided into pulse amplitude modulation, pulse motion modulation, pulse width modulation. Okay, digital modulation are comes pulse code modulation. Their first digital modulation technique is pulse code modulation, data modulation, adaptive delta modulation. Types of AM, FM, PM definition of waveforms. Okay, their types, how that they are divided, and definitions and waveforms are there. The first with the amplitude modulation. Amplitude modulation is a technique in which amplitude of carrier wave, carrier signal or carrier wave is varies according to modulating signal, amplitude of the modulating signal. Okay, amplitude of the carrier is varying according to amplitude of the modulating signal. And in frequency modulation, frequency is varying of carrier signal frequency of carrier signal is varying according to modulating signal. And in first modulation, frequency of phase of the carrier signal is changing according to modulating signal. Though there is waveforms are there. The waveforms we see that amplitude modulation waveforms are this type, and frequency modulation is frequency is varying, and in this amplitude is varying, amplitude modulation amplitude is varying, frequency is varying, and phase is varying. Okay, up next we come to amplitude modulation. What is amplitude modulation? Amplitude modulation techniques of modulation which instantaneous amplitude of carrier signal varies according with amplitude of modulating signal, while frequency and phase of carrier remains constant. So frequency and phase remains constant, and the amplitude of the carrier signal is changing according to modulating signal. This type of modulation is called amplitude modulation. So there is diagram of amplitude, how that amplitude modulation is there. Amplitude modulation, that modulating signal, electrical signal equivalent, carrier signals, high frequency, amplitude modulating signal. And then it comes under the modulation index. What is modulation index? Modulation index is the quality of the signal. What is the quality of the signal? Is that it modulation signal amplitude, carrier signal amplitude. If modulation index is expressed in percentage, it is called percent modulation. Percent परसेंट है ना, that is B maximum minus voltage maximum and B minimum upon user plus B minimum. Okay, the modulation index is equal to a ratio of modulation amplitude and carrier signal amplitude. See, it is important. Modulation index is very important. There is 100% quality, 100% is there, then the quality of signal is 100%, and this is called modulation. Okay, if there is 110%, then it is called over modulation, and this if come in if 100% lower than 100%, then it is called under modulation. That is defined, and that is seen in the diagram that is there here. What is that modulation index role? Okay, then